All right, well, here we are, and welcome to my ham shack. This is where I do my communications. This is where I work with radios and do things. And right now you're looking at the radio that we're going to use for this. It is a Yaesu FT920, so that's an HF and 50 megahertz transceiver. What does that mean? That's that long distance communication we talked about, the type that skips off the atmosphere and can go over very long distances. Now, a lot of the time I'm operating it with a hand microphone, like this, okay? And that hand microphone would let me talk to people with voice. And of course, we've done a little bit of voice work in the classroom using some handheld radios. So we're not really all that interested in doing voice communications at this point. We're going to talk about digital communications. Today we're going to look at something that we call FT8. And FT8 is a digital protocol that works really well for weak signal work, but of course it can work well with good signals in addition. So right now you can see that the radio itself is tuned to 14.074.00. Why two decimals? Well, those are just separators. So it's 14.074 megahertz. Okay? And it's 00, so it's right on that. I also have my secondary side set up here. Okay? To the same thing. I would normally be on that channel, but I wanted to put it on the primary because it's a bit bigger and easier to see from your angle. But I normally have that as a secondary channel because that is something that I commonly use, this frequency. The little blinking indicator up here, EXT, is indicating that there is external control of this radio. And that external control is actually coming from here. This is the application. Yes, it's a Windows application, I know. But it's an application that uses the radio like it's a modem. So it's kind of interesting. There's an interface between the computer and between the radio that converts the audio levels that go into a computer and out from a computer into the audio levels that go into a radio and out from a radio. Okay, so that's sort of handled for us, if you will. So if we're looking at this screen now, what you're seeing on the left-hand side is what's happening on the band in general, okay, and what's being received on certain frequencies, okay? So you can see the frequency offsets here that are being used, and you can see the communications, and this is sort of a band overview, if you will. Down here, you can see 14.074.000. That's right. There's actually another decimal point that you can't see on the radio's display, but it is in here. So that is the frequency that we're using, and we're using what's called upper sideband. And you can read about sidebands, of course, in your textbook. So, what are we doing right now? Well, we're watching, okay? And we're seeing things coming in here. So these things that say CQ right here, that's an American. KG, that's an American call sign, okay? IU, that's Italy, and it says so over here. But you know that just because of what comes before the digit, okay? G3RIK, that's England, right? So, yeah, some of these are not decoded into nations, and I'm not quite sure why it's not doing that, because this KD is also an American station. But yeah, so there we have it. Oh, there's Netherlands. Okay, pretty cool. So what you're seeing here is you're seeing greens are stations I've never heard before, and this pink one would be one that I have previously communicated with. So it's kind of cool. Now, if you look down here in the corner, what you're seeing is it's counting up seconds. And this is using 15-second time bands. So in that sense, it's a bit like slotted aloha, except that there's only 2 slots that are being used, okay? And so therefore, the entirety of the transmission time is 30 seconds. Now, of course, when we're using even aloha or slotted aloha, We're using much faster communications than this, and modern wireless communications are so fast that it's very difficult to actually capture them in real time and analyze them. They just go too fast. You'd have to capture the data and then dissect it afterwards. So the advantage here is that you can actually watch this happening as it's happening. Okay? Now, this stuff that's sitting in here is from the last time I made contact with somebody. Okay? I made contact with this SV station. And this is automatically configured. These are general standard messages, okay, that are automatically generated for me. And what I can do is I can enable my transmission, and then all I have to do is pick somebody to talk to. Okay, here's a guy here that's CQ IOTA, and he's trying to make contact with islands on the air. I could technically go in for that if I wanted to, but I'm going to keep it simple today. Okay, we're going to get ready here to do some transmitting. And the first thing I want you to note is down below where the 1407400 appears, to the right of that is a TX 1319 Hz, and then under it an RX 1319 Hz. Normally in this mode we transmit and receive on the same frequency. So that frequency is what is being monitored over on the RX frequency window on the right hand side. So the band activity is the entire band, and the RX frequency is just around the area that I'm trying to communicate on. And you can see there are multiple conversations going on in that space. That's one of the characteristics about this. So I'm getting ready here to transmit a CQ, which is a request to anyone, please talk to me. So yeah, I'm going to do that in just a couple of seconds here. I noted a little bit of red there. That's where somebody is calling me because I did enable my TX a little earlier. But yeah, so I've just enabled transmit, and it's sending out now a CQ signal. Okay, the first time I tried to do this, I realized, whoops, I forgot to flip a switch on my interface, which actually says allow the interface to control the radio and put it in transmit mode. We have lots of safeguards when we are working with radio to make sure that we don't set up something and make it completely insane. So here it is again. It's sending out that CQ, this time for real. So at 18:20:45, that is UTC, so that's Coordinated Universal Time. You're able to see that I'm sending that out, okay? And that's a 15-second window for that, and now I'm listening. And I'm hoping that I'm going to hear a response to that. So we'll see in a couple of seconds here because it's decoding. Ah, look at that. 2 people came back looking to talk to me. One of them is an N station, and that is from the United States of America. So we're going to go and pick a station, and we're going to call them back. So we picked the N station by clicking on them. They're now below the general band frequency, 14074. If you look down, you'll see that call sign that's listed there. It starts with N. Okay? And in fact, we've completed a contact. So basically, he sent to me that he was receiving me with a certain signal level. I sent to him that I had a certain signal level for him. And then he basically said, okay, thank you. And I said, okay, thanks, and bye-bye. So that's what you're seeing there on the side of the screen. The pop-up window is a log entry where I can put that in. So right there, you can see that I gave him a signal of -07, and he gave me one of received signal of -01. Okay, and then I sent Roger Roger 73, and he sent back 73, which is the last and final response. You'll notice there's another call sign in there. It's an EI station, and it's trying to communicate with me at the same time as I'm talking to this other guy. Okay, so there can be multiple people trying to communicate with you, but this protocol allows for multiple signals to exist in the same space. It's kind of cool. Anyway, that's FT8, and of course, the key to this is the fact that there are 15-second phases, and there are effectively 2 phases in an exchange. There's 2 slots. So either you're transmitting in the first slot or you're transmitting in the second slot. And if you hear somebody in slot 1, you transmit in slot 2. But if you hear them in slot 2, you transmit in slot 1. It's very, very simple, and it's like a very basic version of slotted aloha. Anyhow, hope you've enjoyed this video and watching the technology. And if you want further information, please let me know.